Well, hello, class. So you see double me over here. It is the way it is. So I am going to use my iPad and write on the guided notes for this section. So this section is 3.1, simple interest. And so we're starting this section on the different interest formulas, which if you've taken your economics, you could have seen these. They're also in Math 1000 if you happen to take that course. But let's go through this. So the first idea here is simple interest. So simple interest is just the idea that you're going to get one amount of interest. So typically at a bank, you might find a CD, or like if you're paying back your friend that you borrowed money from with interest, they might do simple interest. It's actually not as common as compound, which is our next section. So let's look through everything that we need for simple. So simple, the idea is I is interest, okay, equals PERT, principal times rate times time. Now, your rate, you have to rewrite this as a decimal. So this becomes really big idea here. You got to make sure you move your decimal. Otherwise, your number will look really big because instead of multiplying by 5%, 0.05, you might do 5, and that makes the number huge. Okay, and then notice the time is in years, and principal is the amount you start with. And that's where the P comes from, is it's not the principal at the school, it's your principal amount of money. Okay, so why do we have a second formula? Because this one is our future value. So future value. So what this one does is it includes your original amount plus your interest. So up here, this is only what did I make in interest? Nothing to do with adding it back to that principal to see now how much money do I completely have. Another way to write this could be principal plus PERT. Equals A. I kind of wrote the A on the opposite side, but so these two are the same thing. So this and this are the same thing. So just so you're aware, this one kind of leads us towards the formula for compound interest. So it's probably why they write it that way. So let's do a couple examples. If Miss Gonzalez borrows $1,000 for 4 years from a bank that charges 5% simple interest, how much will she owe at the end of 4 years? So how much in total interest plus principal will she pay to the bank at the end of the 4 years? So the first question is just, well, how much interest? So we know our formula for interest is P times R times T. And let's go ahead and calculate that one. So principal, how much money did she start with? She started with $1,000, okay? And then what is her rate? 5%. How do I write that rate as a decimal? Move the decimal 2 places to the left. So it's 0.05. And then we times that by our years, which was 4 years. I just realized I probably should have a calculator handy, right? I don't want to bounce between the app that I have on my iPad here. So 1,000 times the 5% times 4 years is $200. Okay, so if I wrote that correctly, it looks something like that, $200. All right, so that's our first question. So the second question says, how much in total interest and principal? So what is her future value? So we could easily follow what is up here with this PERT plus P, because we could just go, okay, well, the future value, A, would be the $1,000 plus my interest. So $1,200. Okay, so Miss Gonzalez will have to pay $1,200 at the end of 4 years. Okay, Mr. Q, is that how you'd say XU? Q? I don't know. He borrows $3,000 for 3 years, and the bank charges 2% simple interest. How much interest will he owe at the end of 3 years? Okay, so same question. So why don't you pause the video, see if you can figure this out, and unpause, and I'll give you the answer. Okay, so here's the answer for this one. It's very similar. So interest is going to equal $3,000 times our 2% times how many years? 3 years. Okay, so our interest is 180, I believe, 0.02 times $380. So the future value is going to equal 3,000 plus the 180. So they will have to pay back $3,180. Now you will never get 2% or simple interest for that matter. So that one's a little unrealistic to me. Okay. So problem 3 has only half of a year, so it's a good one for us to do. Mr. and Mrs. Smith are running short of money this month, and they decide to borrow $500 from the bank and repay the money in 6 months. So it's not a full year. When they get their income tax refund check, the bank charges 6% annual simple interest. How much interest will they have at the end of 6 months? So it's still that same, how much interest? So we have our PERT. So we're starting with borrowing $500. Our rate now is 6%, and our time is always in years. So how can I represent 6 months in years? Is it 6 out of 12 total, or 1/2? So you could do this for 1 month, 2 months. You just put it over 12. I mean, this one's 1/2, so it's a little bit easier. So if I calculate that out, it's actually $15. I wish it was that cheap. So what is the future value? The future value would be 500 plus the $15, which was a total of 515 that she will have to pay back at the end of the 6 months. I think about the time on that one. Okay, so the next one is similar. These ones just basically switch it up. So problem 6. 6 is a little bit different. So find the amount needed to pay off a simple interest loan of $2,000 at this rate. So find the amount needed to pay this one off. So we need to look at our future value formula. A equals P times 1 plus R times T, or you could use the other version of P plus PERT. Those are the same thing. And let's fill in what we know. So we're going to pay off. Well, we have our, that's not that tricky. I was thinking it went the other way, but find the amount needed to pay off the simple interest loan. Well, we're just going to put in our information. We still could do this as PERT and then add it back. Totally fine. But let's do it this way. So we start with a borrowing $2,000. This is the number 1 plus the rate is 0.105. Go all the way out, right? Times the 3. Okay. So put it in just like you see it with the parentheses in your calculator. So 2,000 parenthesis 1 plus 0.105 times 3. So I put it in just like I see it. It's backward. Forgot my image is mirrored, but I get 2,630. This is our future value. So there's using that future value. So the problem I thought we were doing is problem 7. Okay, what amount needs to be invested today at 4% in order to have $6,000 in 3 years? So let's write our formula down again. A equals future value equals P times 1 plus r times t. And this time we have a goal of 6,000. That is your future value. It's not the money you have now, because you're asking how much do I need to invest right now to get there. So we want to get to 6,000. We don't know P, but 1 plus our rate is 4%, and we have 3 full years. So here's our formula. So we can combine everything in that parenthesis and then divide that over to 6,000. So 1 plus 0.04 times 3 is 1.12. So P times 1.12 equals 6,000. So to solve for P, this is times, right here is a times, right? So in order to solve for P, I need to divide by the 1.12, divide by 1.12. So 6,000 divided by 1.12 is 5,000. So our principal amount would be $5,357.14. I have to have that much money right now to put into this account to have 6,000 in 3 years. Okay, so 8 is the same. So let's look at 9. They do a lot of double. So 9 says, how long? So this is a different one. Fred would like to buy a new computer, but he only has $500, and a new computer costs $900. He can invest the $500 in an account that pays 4% simple interest. How long will it be before Fred can save up and buy this new computer? Do you think the same computer will be offered at the same price when he has saved the additional $200? Yes or no? Okay, so let's figure out, first of all, how long it's going to take this guy to save up his $200. So we have A equals future value equals P1 plus rate times time. So we know that the future value is $900, and we have money right now. We have $500, right? And then 1 plus, what was the rate? 4% times, I don't know how long. So times t. And then we got to solve this one. So we're going to start by, this is a times here. So we got to start by dividing the 500 over first. And 900 divided by 500 is 1.8. Okay, so I have 1.8 equals 1 plus 0.04 times t. Okay, I don't really need the parentheses. I don't know why I wrote those there, but this is kind of the cursive T, so it doesn't look like a plus. There we go. That looks better. Okay, so we don't really need this parentheses, so maybe I'll erase it. Oh, it erased my 500 up there. Oh, well. There we go. I'm like, oh, and my T became not cursive. There we go. All right, so we have to solve for this T. So we have to get rid of this 1 first. And that's going to leave me 0.8 equals 0.04 T. And then I can divide by the 0.04 on both sides. Oops. So 0.8 divided by 0.04 is going to give me 20. It would take me 20 years to save this $200. Yes, we need some compound interest where you gain interest on your interest. Do you think computers will change their value in 20 years? Yeah, I think you're going to need to borrow that money from your mom. Okay. I think that's pretty much, like, I mean, there is some more examples on this note packet, but I think we're good there. There are still some more examples from the company that you can see in the lecture section in my math lab. So if you need more help, but I think this is good enough. Hey, catch you later.